Today's lesson is on changing fractions to decimals, and our standard says to convert a rational number to a decimal using long division, and to know that the decimal form of a rational number terminates or repeats. So we're going to take a lot of written notes today, so just be sure to follow along. And if you so choose to use the color coding tactics that I use, feel free. But you might want to take a moment to gather some colored pencils or pens or whatever you think you're going to be using today. So the problem we're going to focus on as a whole is going to be 4 3/8. And what we're going to do with that problem is we're going to change it from a fraction to a decimal. Step 1 is to turn the mixed number into an irrational fraction. And of course, this is only the case if you are given a mixed number. If you're given a solid fraction, then step 1 is not necessary. However, if we're turning a mixed number into a fraction, just like we've had in the past, we want to take the number of parts in the whole and multiply it by the number of wholes that we have. So if there are 8 parts in a whole, I multiply it by the 4 wholes that are included in my mixed number. That's going to give me 32 pieces that would make up 4 wholes. Then I'm going to add the 3 pieces that are already existing in my fraction to bring me to 35 total pieces out of a whole that is made up of 8 pieces. So now I have an improper fraction of 35/8. Step 2 is to certainly remember a fraction is a decimal. And a fraction is always a division problem. Just like we discussed in video number 9, fractions are always division problems. That's why it's so important to know what's my numerator, what's my denominator, and to keep everything aligned. So we're going to set up the division problem. And we need to remember that the top of the fraction drops into the house. So remember, the top drops in the house. And you might be a little unclear as to what I mean, but if I have a fraction that is 35/8, the top drops into the house. So my division problem is 8 divided by 35. Step 3 is to simply divide. So 8 goes into 35. 8 cannot go into 3, but 8 can go into 35. 4 times, and 4 times 8 is 32, so I do my subtraction, and I have a 3. At this point, I want to be able to bring a number down because I don't have a value that can be easily divided by 8, but I can't do that without inserting a decimal point and creating another value for myself. So I need to insert a decimal point after my 35 and extend that number using zeros. I'm not changing the value of the 35. I'm just extending it so that I can create a division problem that's a little more substantial. Instead of saying 4 remainder 3, I want to actually know 4 what? 4 and 300ths, 4 and 75 thousandths, whatever I want to do. So once I insert my decimal point in my zeros, I can continue dividing just as I normally would. I bring down that next 0. 8 goes into 30 3 times. 3 times 8 is 24. Subtract, and I get 6. Again, 8 doesn't go evenly into 6, so I need to bring down another 0. 8 goes into 60 7 times. 7 times 8 is 56. Again, subtract, so I get a 4. Bring down my 0. 8 goes into 40 5 times. That's great because 8 goes into 45 times evenly, and I've completely divided out my 8 into 35 to 3 decimal places. Let's jot down a couple of notes about this process specifically. Once you get to a remainder, I'm going to put a big R for remainder. You want to add a decimal and zeros to the inside number. Usually I add 1 0 at a time to decide how many I'm going to need total, but if you add a few, when you realize that you don't need them anymore, you can just stop using them. But now you have something to bring down. So you're going to continue dividing until the decimal terminates, repeats, or you round. And these are 3 things we're going to talk about specifically. Until the decimal terminates, repeats, or you round. I want to give you some definitions for those terms there. A terminating decimal is a decimal which comes to an end. Just like our last example, there was a point at which I could stop bringing down zeros because I had brought 8 into my 40 evenly and I didn't have to continue on, right? It does not go on forever. A repeating decimal, however, will have repeating patterns of digits. And it will go on forever. The point at which you stop dividing is when you realize you have a repeating decimal. So if you do 3, 4, 5 decimal places and you're starting to see a pattern, you may stop. You can use what we call the repeating sign or repeating bar. For example, 1/3 as a decimal is equal to 0.333 repeating, and it will go on forever. But in order to avoid writing all that out, I just put a little repeating bar above my last 3, and that tells me that that decimal will repeat forever, so I know that that's the case. Lastly, you could round. And rounding is fairly typical if a decimal does not terminate, right? Because if it terminates, then we don't have to worry about rounding. But if it does not terminate, we round. And rounding decimals is very similar to rounding whole numbers. You want to kind of use this guideline as a rounding guideline with the numbers 0, 1, 2, 3, and 4 below the mark, and then 5, 6, 7, 8, and 9 above the mark. If you're at 5 or up, you round 1 digit up, right? But if you're at 4 or below, you stay the same. For example, if I had the number 2.5679, and I wanted to round it to the hundredths place, I look at the neighbor next door, and I say to myself, is it above 5 or below 5? The 7 is above the 5, so I want to round my 6 1 digit up to 2.57. That would be a rounded solution to the hundredths place. We'll practice rounding a little more as we move on throughout the week. For your proof today, you are going to write 6 4/6 as a decimal. Please show all your work, especially your long division, so we can follow your process and make sure that you're doing everything correctly and that you're understanding these